Hello friends, welcome to my channel Learning Electronics. In this lecture, we are going to study step down chopper with resistive load. So under this topic, we are going to study first principle of operation or working of step down chopper with resistive load. Then we are going to do derivations of average output voltage and current. Then derivation of RMS output voltage current. Then derivation of output power and derivation of effective input resistance Ri. In the last class, we have seen the introduction and basic concepts of DC chopper. So if you want to see that video, you can check it in the channel playlist. So before starting this video, please subscribe my channel and also press the bell icon so that you can get more updated videos from here. This is the circuit diagram of step down chopper, which is also called as buck converter. So here we can see that the DC voltage source Vs, a switch SW, and the resistive load is connected in series with each other. This step down chopper is a static device that steps down or lowers its DC input voltage. Therefore, it is called as step down chopper because it lowers the input DC voltage. Therefore, in this type of chopper, the average output voltage is less than the fixed DC input voltage. So here we have taken the average output voltage as V0. So in the step down chopper, this average output voltage or load voltage is less than the input DC voltage Vs. Here we can see that one switch we are using. So this step down chopper uses power devices such as power MOSFET, power BJT, GTO and Force commutated SCR as switch. Next one is principle of operation of step down chopper. In this we have connected one switch. So when switch SW is on, at that time it will act as short circuit. So when it will act as short circuit, then load current IL starts flowing through this resistive load, and in this condition the load voltage will be equal to input source voltage or input DC voltage. Therefore, we will get VL is equal to Vs when the SW switch is on, and when the SW switch is off, then this switch will act as open circuit. Therefore, no current flows through the resistive load. Therefore, the load current IL will be 0 when the SW switch is off, and the load voltage will also be equal to 0. So we are getting this type of waveform. So from here we can see that during the on period, that means when the switch is on, at that time we are getting the output load voltage VL is equal to Vs up to the instant dt, and when the switch SW is off at T is equal to dt, what happens? The switch will act as open circuit and we will get the load voltage is equal to 0. So therefore we are getting a rectangular load voltage waveform. In the step down chopper, the switch SW is operated with a duty ratio or duty cycle represented by capital D, which is defined as a ratio of on period of the switch divided by on period plus off period of the switch. So from this waveform we can see that this on period plus off period is equal to total time period T here. Therefore we can represent this on period plus off period is equal to T. Therefore the duty ratio D will be equal to on period divided by T. Since we know that 1 upon T is equal to frequency, so we can write D is equal to F into T on here. This F is the chopping frequency, this T is the chopping period, T on is the on time of the switch, and T off is the off time of the switch, and D is called as the duty ratio or duty cycle. Now from this equation we can find out the on period of the switch T on is equal to D into dt. Therefore we have represented the on period here as dt. Now from this output waveform we can see that the total time period or chopping period T is equal to on period of the switch plus off period of the switch. So when we put this equation of on period here, we will get T is equal to dt plus off period of the switch. Therefore off period of the switch will be equal to T minus dt, which is equal to T into 1 minus d. So here the off period we are getting 1 minus d into T. Now we will see the derivations for the step down chopper with resistive load. First one is average or load output voltage represented by VL average. So from this waveform we can see that we are getting the output from 0 to T on. Therefore we can integrate for the average output voltage from 0 to T on. Therefore the average output voltage or load voltage VL average will be equal to 1 upon T integration from 0 to T on VL dt. So in this on period we are getting VL is equal to Vs. Now we will put VL is equal to Vs here. We will get VL average is equal to 1 upon T integration from 0 to T on Vs dt. Vs is a constant. So we will get Vs upon T here integration from 0 to T on dt. We know that integration of dt is equal to T. So here we will get Vs upon T. So this type of equation we will get, we have to put the limit from 0 to T on. So from here we will get VL average is equal to Vs upon T into T on. From the equation derived, we know that T on by T is the duty ratio. Therefore, this VL average will be equal to Vs into D. Now from this equation, we can see that since VL average, that is average load output voltage, is equal to source voltage or DC voltage into the duty ratio. Therefore, by varying this duty ratio, we can vary the average output voltage of this step down chopper. Second one is average load current, which is represented by IL average. Since we are using resistive load here, so the load current and load voltage are in phase with each other. So here we will get IL average is equal to VL average divided by R. We got VL average is equal to Vs into D. So here we will get IL average is equal to Vs into D divided by R. Now we will going to derive the RMS load voltage, which is given by VL RMS, and it is equal to 1 upon T integration from 0 to T on VL square dt. Because we are finding the RMS output voltage, this will be bracket to the power 1 by 2. Now we will put VL is equal to Vs here. So we will get 1 by T integration from 0 to T on Vs square dt to the power 1 by 2. Now this Vs square can come out. So we will get Vs square divided by T integration from 0 to T on dt to the power 1 by 2. Now when we integrate, we will get Vs square upon T limit from 0 to T on to the power 1 by 2. Okay, so from this equation we will get VL RMS is equal to under root Vs square upon T into T on. So this T on by T is equal to duty ratio. So this will be equal to Vs square into D. Now VL RMS will be equal to Vs into root D. So this is the equation of the RMS output voltage or RMS load voltage for the step down chopper. Now we will find out the RMS load current. So since we are using the resistive load, I have told you the load current and load voltage will be in phase with each other. Therefore, IL RMS will be equal to VL RMS divided by resistance. So here we got VL RMS is equal to Vs into root T. So IL RMS is equal to Vs into root T divided by R. Now we will find out the output power, which is represented by P0. The output power P0 will be equal to VL RMS into IL RMS. So here we got VL RMS is equal to Vs into root T and IL RMS is equal to Vs into root D divided by R. So from here we will get Vs square into D divided by R. So the output power for the step down chopper is equal to Vs square into D divided by R. So if we consider the chopper to be lossless, in this condition input power will be equal to output power is equal to Vs square into D divided by R. Let this be equation number 1. Now we will find out the effective input resistance represented by Ri. The input power is represented by Pi is equal to Vs square divided by input resistance Ri. Let this be equation number 2, and the equation number 1 was Pi is equal to d into Vs square divided by R. When we equate both this equation, we will get Vs square divided by Ri is equal to d into Vs square divided by R. So this Vs square and this Vs square will be cancelled out, and we will get Ri is equal to R by D. That means the resistance of the resistive load divided by duty ratio is the effective input resistance for the step down chopper with resistive load. So from this discussion we have seen that the average and RMS output voltage can be varied from 0 to Vs by varying the duty ratio D from 0 to 1 to control the power flow in the circuit, and the duty ratio can be varied from 0 to 1 by varying the on period of the switch or the total time period or chopping period or the chopping frequency. So from the equations of the duty cycle we have derived these statements. So hope you have understood the topic. Thank you very much for watching, and please do subscribe my channel for more updates.